Right. The case is built on the theory of evolution by natural selection. And there's a very simple question. Would evolution by natural selection favor organisms whose sensory systems report the truth about the reality around them?
Don, it's good to see you after, I don't know, 7, 8 years. We had a great conversation. We've used a lot of your ideas, and you've developed it quite aggressively, I would say. Since then, you pose the case against reality, and as I hear that, given COVID-19, the state of the world, politics, domestic and international, I might like a different reality. So I'm all ears, but your case against reality is much bigger. You're going after much bigger game. So let's start by simply stating your case against reality.
Right. The case is built on the theory of evolution by natural selection. And there's a very simple question. Would evolution by natural selection favor organisms whose sensory systems report the truth about the reality around them?
And
That's
truth you're defining as what's really out there in some sense.
that's right. So if we assume that there is some kind of objective reality, and perhaps for sake of argument, we just won't claim to know anything about it, but there is some objective reality and it has some structures. It might have some kind of structure to it, like um, a total order where things can go from small to large, or some kind of geometries, or some kind of notion of nearness, what they call topologies. So we just imagine that there is an objective reality, and it has certain structures. We don't have to commit to what those structures might be, but we ask the technical question: does the theory of evolution itself give us any tools to ask the question, are our senses shaped to show us truths about the structure of objective reality? Now, no one ever claimed that we see all of objective reality, but the question is, do we get shaped by natural selection to see those aspects of objective reality that are necessary for us to survive and reproduce? That's the technical question.
Okay, but theory of evolution relates to a fitness of survival, to the capacity to procreate, and a differential factor between organisms that can procreate and that process continue. So that's the process of evolution.
That's
So I would say that a superficial prima facie case is that if an organism is going to have to deal with its environment, deal with its competitors, its predators, its prey, whatever it needs to do, it has to do that properly in order to survive and to procreation and then the fitness of the population. So the the initial thought would be that there would be a very strong correlation, if not exact, between what the organism has to sense in the environment and what's really out there. So if you're claiming that that's not the case, then shouldn't the burden of proof be entirely on you to disrupt what would be a natural perception on our part?
I think the burden is on me because there is a very obvious and prima facie case to say that we should be seeing the truth. The argument goes like this: those of our ancestors who saw reality more accurately had a competitive advantage in all those important activities of life: feeding, fighting, fleeing, and mating. And as a result, because they were more successful in those activities, they were more likely to pass on their genes, which coded for the more accurate perceptions. So after thousands of generations of that, we can be fairly confident that we're the offspring of those who in each generation saw more accurately. So in the normal case, we should see reality as it is. Again, not all of reality, but those aspects of reality, the structure of reality that we need to survive in our niche. So that's a pretty strong case, right?
Sure. So we need the capacity to be able to identify a predator and hide from a jaguar on the savannah plains, or to identify the differences in edible and poisonous mushrooms, or whatever the case happens to be. We need to have that capacity. We don't need a fitness capacity to understand quantum mechanics, but that's a whole other question.
Right, exactly. So the question then is, right, do our sensory systems report truths about the true structure of objective reality? So we see a world. So the question is, I mean, so people might not understand what this question is. They might say, well, look, I mean, you see a structure all around you, right? I see the zebra, I see the jaguar, I see all these things. I am seeing structure. But the question is this, yeah, we're seeing what we see. The question is the structure of what we see actually being faithful to whatever objective reality is, right? So our sensory systems are, of course, giving us some structures. But the question is, on evolutionary grounds, what confidence should I have that when I see a structure that I call a zebra, that I should then be able to infer that in objective reality, independent of my senses, there is that kind of structure in objective reality. So the question is, does evolution have anything to say about this? You could imagine that evolutionary theory just is silent, but it turns out it's not silent. It has very, very interesting implications.
Okay, now the obvious thing is that, of course, we're not seeing the red and the stripes of the zebra. We have photons that impact on our optic nerve. It goes through various structures in the brain, lateral geniculate body, visual cortex, whatever. And there are certain neurons that code for shapes or edges, and others for color. Color, as we know, we see a very small part of the electromagnetic spectrum as color, but they're different wavelengths. So what we perceive as red has a certain wavelength. So we know that it's not literally a color out there. It's a wavelength that we perceive it. Is that part of the argument?
That's going to be part of the deep question here. Is we will have an experience in terms of shapes and colors and sounds and smells and so forth. And those will all be structured. So our perceptions are highly structured. And the deep question is the structure of our perceptions, um, in some sense, telling us something true about the structure of objective reality? Or is it something, I mean, one could imagine two extremes. One extreme is that evolution has shaped us so that our senses are almost like just a window. Like it's transparent, and the true structure of objective reality is just what we're seeing. So I see a zebra, that's because there is a zebra. I see stripes, that's because that's the structure of objective reality. The other extreme, just to see what's possible, is it could be um, like a user interface. So you're playing a video game, and say, Grand Theft Auto, and what you're seeing, the structure that you're literally seeing is, say, a red Ferrari racing a green Mustang. That's what you're seeing. You're seeing a steering wheel in front of you. So that's that's the structure of what you're seeing. Now, in that metaphor, is that structure that you're seeing truly the structure of the deeper reality, which in this case would be, say, the voltages and magnetic fields inside some supercomputer that's running the whole thing? Well, in some sense, you could see green Mustangs and red Ferraris as much as you want. You would never get any clue that objective reality had no green Mustangs and red Ferraris, that it had voltages and magnetic fields and silicon wafers and so forth. So that's the question that we're asking here. Yes, our perceptions are structured. Did evolution shape us to have something more like a window, maybe not exactly a window, but a window where we're seeing the true structures of reality? Or will we shape to have something more like a user interface, like a game interface, so that we're playing the game of life, but without ever actually seeing the reality on which the game is loaded and being played? That's the
Look,
question.
that makes sense, but the fact that the world is composed of molecules and then atoms and subatomic particles and then ultimately quantum fields and perhaps something below that, string theory or whatever. uh, we know through scientific research that there's all of those things that we then interpret as the zebra or whatever the structure is. But that's sort of a composite, and this is, of course, a whole field of philosophy and Mariology, where what is a real parts, and what are wholes and parts, and that's a whole other conversation. But so we know that we're not seeing the ultimate reality. We don't even know where the ultimate reality will eventually settle. But from your work, you're actually imposing an even more significant case against reality than that difference that between our sense and what's really out there. And that's what I want to understand.
That's right. So just to reinforce what you said, right? We have our perception of space, right? And roughly we feel like we're in a three-dimensional space. But when physicists talk about space and space-time, they have specific structures like Minkowski space, and there's all this mathematics that the rest of us would never even know. And we didn't know about that until Einstein came along. So there's this distinction between what physicists call space and what we call intuitively our space. So that's not what I'm talking about here. That difference is not what I'm talking about here. This is just whether the structure of our perceptions is at all related to the structure of objective reality. Well, and so I won't beat around the bush anymore. It's a theorem of the theory that the probability is zero that any of the structures of our perceptions are homomorphic or isomorphic. Depict is an informal word that our perceptions of structure in some sense capture the true structures in objective reality. So
Okay,
it's a theorem.
I've seen that in your paper, that you say that the probability of that is zero, and let's understand the logic behind that.
So the idea is this: evolution has been turned into a mathematically precise theory. It's called evolutionary game theory. And the word game is really helpful here, right? In games, you're playing for points, right? You get rewarded by doing things right and punished for doing things wrong. And in evolutionary game theory, there are these notions of fitness payoffs, right? So fitness, you want a fitness payoff is something that you want in terms of more points in a game. So a fitness payoff depends on whatever the state of the world is, right? But it also depends on the organism, like tiger versus human versus cheetah and so forth. Its state, hungry versus full, and the action of feeding, fighting, fleeing, and mating. So if I'm hungry and I'm looking to eat, then maybe a steak is going to give me high fitness payoffs. If I'm a lion and I'm looking to mate, that steak gives me no fitness payoffs whatsoever, right? So it depends on the organism, its state, and its action. For a cow, there's no action in which a steak is of high payoff value for the cow, right? So the idea then there are these fitness payoffs that guide our success. And the technical question is this: a fitness payoff can be thought of as a function. It's a function from the state of the world with all of its structure into a finite set of payoff values, maybe from 0 to 100 or 0 to 1,000, whatever discretization you want. So 0 means really bad payoff, 100 means really good. And so our senses will be tuned to the fitness payoffs, right? We learn to do things, to act in ways that give us greater fitness payoffs. And we learn to perceive how to get those greater fitness payoffs. So the question is, if evolution tunes our senses to the fitness payoffs, does that mean it's also tuning us, therefore, to the structure of objective reality, which is just the domain of the fitness payoffs, right? So the fitness payoffs are a function. They have a domain and a range. The domain of the function is, at least in part, objective reality. So the question then, as a technical question, is this: are the fitness payoffs functions that preserve the structure of the world? The technical term is homomorphisms. Are fitness payoffs homomorphisms of structures in objective reality? Clean technical question. And So we can use combinatorics. We can say, for example, suppose the world has a total order, that there might be states like the amount of water that goes from zero to a high amount, where it's a total order. You can have, you know, little, a lot, and very, very, very much, or something like that. So that's a total order. You can have a notion of a topology, things that are close to each other or near to each other. You can have a metric. You could have symmetries, like a group, what we call groups, symmetries. So for each one of these structures, you can ask the technical question, what is the probability that a randomly chosen payoff function will be a homomorphism of that structure? And so what we do is to count them, we just assume that the world has some large but finite set of states. And we can then, so we have n states in the world, n as in Nancy, and we have m as in Mark, payoff values. And we can literally count all the payoff functions. If you have n states of the world and m payoff functions, you can compute that, it's m to the n total payoff functions. And then you can ask, what fraction of those payoff functions, how many of them would actually be a homomorphism? And you just put those in the numerator. So the number of homomorphisms divided by the total number of payoffs, and then let those two numbers, n and m, go to infinity to find the answer. And what we find is we've done total orders, we've done measurable structures, a couple kinds of group structures. Every case, the answer is precisely zero, precisely zero. And it's no surprise. The reason it's no surprise is for a payoff function to be a homomorphism, it has to satisfy certain equations. Most functions just won't satisfy those equations. That's why the probability is zero. So in retrospect, it's actually obvious that natural selection couldn't tune us to true structures of the world, because fitness payoffs aren't about preserving the structure of the world. They're about telling you what you need to do to stay alive, which is different.
Okay, I follow all of that, and I've looked at your papers, and what I'm trying to do is find out which of the assumptions in my mind gives me the most problem.
Sure.
Because conceptually, I certainly agree that our perception of the world is not an exact homomorphism or exactly the same. We know that because of what we get as sense data as opposed to what's in the real world. We know that. But you're making a larger claim than that. And I think one of the problems I have is that, are you not assuming that all of the fitness outcomes have the same weighted probability in some sense? That's number one question. Second question is, are you not also assuming that that if a fitness function is not exactly a representative of the homomorphism in the real world, that you're counting it as zero, as opposed to some gradient where most fitness functions will be very close, but not exactly to the real world?
Two excellent questions, Robert. So on the first one, yes, we're assuming that all payoff functions are equally probable. And the reason we do that is because evolutionary theory gives us no reason to choose any other assumption. So I would be very happy for someone on principled grounds in evolutionary theory to say that there is a bias on the payoff functions. But right now, if you look at evolutionary game theory, there are simply, in evolutionary theory as it currently stands, there is no principle by which we could choose anything else but the uniform measure as the right measure for this.
Okay, I agree with you there, but that doesn't mean that it doesn't exist. I think by making all of the fitness functions a priori exactly the same weighting, you're introducing an artificial way of thinking that almost forces you to have a zero probability outcome, because you're letting that go to infinity, and you divide by infinity, you get zero.
Absolutely. So you could put the argument this way: we're throwing out a challenge to say, can someone give a principled reason on evolutionary grounds for a different measure, for a different probability on these payoff functions? If so, I would love to understand the biological or physical insight that justifies something other than a uniform measure. So absolutely. And if someone came up with that, then I would be delighted to hear it. But right now, there's nothing on the table. So that would be, but you're absolutely right, Robert. That's exactly the right kind of response to our theorem, is for someone to say, aha, there's this feature of evolutionary theory that either you've overlooked or that no one's ever discovered before, which says that, no, there is this biased measure on these payoff functions. And then actually you have to take it one more step and say, with respect to that biased measure, these have probability greater than
Yeah,
much.
and maybe we just can't do that. And maybe there is a principle, maybe there's not. But even if there's no principle, it may be just the brute fact that it's there, that you can't take each one and derive a principle for it. Maybe you can, but we haven't done it. But even if you can't, it still may be there.
Well, it still absolutely, and so I don't deny that it still may be there, and I would be, if someone found such a principle, I would be delighted. I would be delighted to have the theorem shown wrong. I mean, that's how we learn this. So you make doing is playing precise claims, and then now we know exactly precisely what someone has to do to take me down. Right? They have to give not just a hand wave that maybe there's another measure. They have to give me a precise measure that's not the uniform measure, explain why that's the measure, and then prove that that measure leads to the result that we would have vertical perception. So there's some serious work to be done.
Look, I think what you are proposing is a radical challenge of conventional wisdom, even a perceived conventional wisdom, maybe that we didn't even realize we had, and therefore deserves high attention and tough questioning and tough analysis. And I know you love that, so that's what we're that's what we're trying to do, because your claim is a remarkable one. So let me go to the second part of that claim, and that is, if a fitness outcome or function is not exactly, but is 99.9% of reality, just missing something, you're still counting it as a zero. And isn't there not a gradient in each case?
That's right. So we've been starting to analyze that as well. So and it varies from structure to structure. So in some structures, it turns out that most of the payoff functions are close to homomorphisms, even though they're not homomorphisms. And
Okay,
for
that makes sense.
most are not. So in the case of a total order, for example, most payoff functions are not even close to being homomorphisms. But in the case of a measurable structure, most are. And for the two symmetry groups that we studied, one symmetry group, I think we found that most are close, and for the other one, most are not close.
Hmm.
So that's going to be a case-by-case analysis. Now, would that give someone what they needed to substantiate the claim that our perceptions have been shaped by natural selection to report true structures of the world? And here's a problem with using that kind of thing, that some of the payoff functions, many of the payoff functions are close, to say, therefore we're being shaped to see
Yeah.
the true structure of the world. And the problem is this, that if you have a particular payoff function and it's, say, close to being a homomorphism of a total order, but not quite, it's also going to be close to thousands, billions of other structures, but not quite.
Hmm.
So now if someone wants to make this argument, they're going to have to explain to me why it is that we could count that payoff function as shaping me to be having perceptions that are close to vertical of the total order, when there's a million other structures that it's also close to. Now, I'm not saying that that argument can't be made, but I'm saying that there's some work that needs to be done for that counter argument. You would need to explain why we would be able to say, of the many, many different real structures that is close to being a homomorphism of, why should I say that only the true structure in the world is the one that I'm counting as it as? So there's gonna have to be, there I say the burden of proof is now on the person who wants to make that claim, right?
I'm not clear on that, because if the difference, if it only gives a 10% function because I need to survive by seeing, I don't know, a change in an edge, but everything else is total confusion. But because I'm a paramecium and I need to see edges, that 10% of reality makes me survive and procreate. So that's one case. Another case may be I'm seeing everything perfectly, 99% except one outside color is misrepresented in my mind, but there's no effect on my fitness capacity. So you're evaluating both of those cases with the same weighting?
Right. So the idea is that um, the fitness payoffs are just telling you that regardless of whatever the state of the world is, if you take this action, you will do well. If you take that action, you will do poorly.
Right.
There's 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 nothing in principle that says you actually have to see this structure in the world. So the only way that we're going to actually get evolution, see, evolution by natural selection is only going to tune our senses to the true structure of the world if it just so happens that the structure of the payoffs is homomorphic to the structure, that structure in the world. But if it's not homomorphic to the structure in the world, you're perfectly fine. Because all you have to do is, like, it's again, take the video game analogy, right? Do you need to know about the diodes and resistors and voltages in the computer to be the world champion at Grand Theft Auto or whatever game it is? No, you just have to know about the structure that the game gives you.
Correct.
Steel wheels and Ferraris and Mustangs and gas pedals, all that's there just as payoff functions for how to win the game. And notice that those payoff functions tell you nothing about the voltages and magnetic fields. And so that's what evolution is. So the only way that evolution would shape our senses to show us the truth is if somehow the game happened to have the same structure as the world. And so that's what I'm asking is, what is the probability that the game would have the same structure as the world? And I'm saying for an unbiased measure, now you make a good point that I'm using an unbiased measure, but for an unbiased measure, that probability is 0. So it's a legitimate question to ask about what is a biased measure that we could argue for. But there's nothing that says to win the video game necessarily you have to know about voltages, right? And that's the same thing about, we don't have to know the true structure of the world.
And that's why you use this very nice term, interface theory of perception, as opposed to a kind of a perception realism. You use an interface theory of perception as your way of characterizing this.
That's right. So I take our senses as being realists about payoffs, right?
Mhm.
So our senses are really reporting payoffs,
Right.
and not perfectly, right? You just have to be a little bit better than your neighbor, right? Right. So evolution does not even shape us to be
That's a good point. Sure.
with payoffs. As long as you're better than the competition, you're good. So even there, we're not designed to truly see exactly the right payoffs. So by the way, I'm not being veridical about payoffs. We don't see even payoffs. We don't see exactly right, right? But much less, I'm saying, is the chance that we see any of the structures of objective reality. And right now, until someone answers brings up the question that you brought up and answers it specifically about is there a biased measure on the set of payoff functions?
Look, it's a really important question. People have not asked it before. My
Right.
great admiration for pushing it, and as I said, as Carl Sagan famously said, extraordinary claims demand extraordinary evidence. Thank you for watching. If you like this video, please like and comment below. You can support Closer to Truth by subscribing.